Hey everyone, today's lesson is on critical points. Um, the first derivative can provide us with a lot of significant information about the graph of functions, and we're going to investigate what it is that it tells us. So, given the graph that you have on your page right now, I'm going to put on some key points for you. The first one is here at A, here at B, here at C, here at D, here is E, and here is F. For the purposes of this example, the graph only works in this range, so there's nothing on either end and it doesn't keep continuing on in either direction. So, looking at the graph and looking at the letters that I've listed, what are the endpoints? And hopefully you'll tell me that they are at point A and point F. The absolute maximum, that is the highest of all the maximums. So the highest point that this hits is F. The absolute minimum is the lowest point on this graph of all the lower points. That's C. The local maximums are all the points where there is a maximum. In this case, that's B, D, and F. And the local minimums are all the places where you have a minimum. So that would be A, C, and E. Now, the maximum minimums, also known as a critical point, so these are the same thing, are found using the first derivative test. Basically what that means is you set the derivative, f prime of x, equal to 0. We also want to be able to set the derivative equal to undefined. So we can say it like this, we can say it like this, or we can say it with the words. Basically what I'm saying is that the denominator is also set equal to 0. In the above example, B, C, D, and E are all examples of maximum or minimums. A and F are endpoints, so they are not technically maximums or minimums when it comes to solving. Now, looking at the graph that's below, notice that the graph of the function is f of x. Sometimes in the IB they like to say the graph below is the graph of the derivative. So be specific and make sure that you're looking at the instructions and that they match with the graph that's given to you. Now, it says here, determine the location of any local maxima. Are there any local maxima? No, there are not. Are there any local minima? Yes, there is. It is here at -1, -6. Determine the intervals where the function is increasing, where that means where the slope is positive. Where the slope is positive from here onwards. It's always going up. So from -1 to infinity, and I can write it with round brackets. And find where the function is decreasing, and notice that's from -infinity to -1, everything from here to here. So -infinity to -1. Again, I'm using round brackets notation. If you don't like that notation, you can say here where x is greater than -1. That's an option for you. Or you can, for the next one, say everything where x is less than -1. It really depends on what you prefer. Next. So let's try it in the way that the question would say. So the question would say, tell me what the critical points are and state the intervals of increasing or decreasing. So what I've done is I've broken down the question into several stages. So the first one says, step 1, find the derivative. That should be pretty easy for us now. F prime of x is 3x squared minus 6x minus 9. Great. Then it says here, find the critical points, and that's by setting the derivative equal to 0 undefined. Because there's no denominator, I'm not setting it equal to 0. I'm only setting the numerator, in this case, what I have, equal to 0. So I get 3x squared minus 6x minus 9 is equal to 0. I'm going to take out a common factor of 3. I get x squared minus 2x minus 3 is 0. I want a product of -3 and a sum of -2. My numbers are x minus 3 and x plus 1. Therefore, x is equal to 3 and x is equal to -1. I'm then going to find the intervals of increasing or decreasing. We know how to do this as well. I'm going to make my sign table. -1 goes on the sign table, so does 3. X minus 3 and x plus 1. I'm going to pick a number less than negative 1. So negative 5 is an example. Negative 5 minus 3 is negative. Negative 5 plus 1 is still negative. I'm going to pick a number between negative 1 and 3. 0 is a great answer. 0 is minus 3 is negative. 0 plus 1 is positive. Pick a number bigger than 3. 5 is good. 10 is good. Doesn't really matter. 5 minus 3 is positive, and 5 plus 1 is also positive. Taking my table, negative times a negative gives me a positive. Negative times a positive gives me a negative. Positive times a positive gives me a positive. This goes up, then down, then up again. That's what's happening with this curve. Therefore, if it goes up and then down, there's a maximum here at negative 1. If it goes down and then up, there's a minimum here at 3. So it says here, state the critical points. Well, there's a maximum at negative 1 something, and there's a minimum at 3 something. Well, how do I find the somethings? Well, I'm going to take negative 1 and plug it back into the original function up here. I'm going to do some number crunching, and when I plug in negative 1, I get out 6. When I take 3 and plug that into the original function, I get out negative 26. So my maximum is here and my minimum is here. I can also state the intervals of increasing. This function is increasing from negative infinity to negative 1, and it's also increasing from 3 to infinity. It's decreasing from negative 1 to 3. And I'm done. That was fantastic. Here's my next example. It says here, for this function, where x is an element of real numbers, find the critical points and the intervals of increasing or decreasing. This time, I didn't break it down into stages, but the process of doing the question is the exact same. So let's start. First, find my derivative, which is 60x to the 4 minus 180x cubed minus 240x squared. Set it equal to 0 and take out a common factor. I'm going to take out 60x squared, which leaves me with x squared minus 3x minus 4 is equal to 0. So I get 60x squared, x minus 4, and x plus 1 is equal to 0. So my zeros this time are 0, 4, and negative 1. So this one's a little bit more challenging. So I'm going to make my table again. And on my table goes negative 1, 0, and 4. On the side, x squared, x minus 4, and x plus 1. I'm going to pick a number less than negative 1. I'm going to pick a number between negative 1 and 0. I'm going to pick a number between 0 and 4, and I'm going to pick a number bigger than 4. No matter what number I pick, x squared will always yield a positive answer. So that's a pretty easy one to do. Pick a negative number, negative, and then positive, positive, positive. Pick another number. It's negative, 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 and positive. Again, you can do it up and down if you'd like, or you can do it across. It really doesn't matter. It's personal preference. A positive, a negative, and a negative make a positive. A positive, and a negative make a negative. A positive, and a negative make a negative. A positive, and a positive make a positive. This graph goes up, then down. It continues to go down, and then it goes up again. So there is a maximum at negative 1 something. There is a little plateau at 0. And then there is a minimum at 4 something. I go back to the original equation, I plug in negative 1, and when I do, I get out 23. So that's my maximum at negative 1 at 23. I have a minimum at 4 something. I'm going to plug 4 into the equation, and I believe I get out negative 4,352. Well, that's great. Now I also want my increasing. So it is increasing from negative infinity to negative 1. It's also increasing from 4 to infinity. It is decreasing from negative 1 to 4. Despite the fact that there's like a little blip or a little plateau at 0, that doesn't really matter. It's still going down after that fact.